ladies and gents, we're going to do a little bit of revision about circles. Hopefully it will just be a case of doing a little bit of reminding to you. It's not meant to be new information to you. Okay, so circles. We need to know some terms in relation to circles. We need to understand these terms, and you may even, in a foundation paper certainly, get some marks just for understanding what these terms are and being able to maybe label them on a diagram. So, radius and diameter. What is the radius? What is the diameter? The radius is the distance from the centre circle, from the centre of the circle, to any point on the circumference. To any point on the circumference, that is going to be the radius. Normally, it's going to be denoted by an R. Okay, any point on the circumference from the centre, that distance is the radius. The diameter is the distance going through the centre point. So we must go through the centre point from one side to another. So through the centre point from one side to another. That is your diameter. Generally, it will be indicated by a D. Okay, so radius, any point from the centre circle to any point on the circumference, the diameter all the way across the circle going through that centre point. Okay, so that's the two basic terms. What else have we got here? Circumference and a sector. Right, okay. Circumference, the distance didn't want to do that. Circumference is the distance all the way around the circle. So circumference really is a bit of a posh word. It's a word specific to circles for the perimeter, the distance around the outside. If you walk around the outside of a circle, that would be the distance that you ended up walking. Okay, the distance around the outside, the perimeter. Posh word, circumference. A sector. A sector is like a slice of the cake. So from our centre point, we're taking a slice out of the circle. That is a sector. Now, following on from that is an arc. Now, if your sector is a slice that's taken out from the centre point, don't forget, the arc is then the distance along the circumference that relates to that sector. So that distance there is an arc length. Okay? You've got a sector, you've taken that sector slice out. The distance that's measured along the circumference that relates to that sector is an arc length. So that's an arc length. Okay. What else do we need to know about? And I'm very, very quickly going through these. We need to know the idea of a chord and a segment. Now, a chord is a straight line doesn't have to go through the centre of the circle. Okay, so that's a chord and a chord length. Okay, and that will give you a segment. So a chord is a line that doesn't have to go through the centre circle. It goes from one point on a circumference to another point on the circumference, and it divides the circle into effectively two segments. You've got a segment here, and obviously you've got another segment over the other side of the line there. Okay? So we should know and understand what a radius is, a diameter, the circumference, posh word for perimeter, sector, we've taken a slice out, an arc, which relates to the sector, and then a chord and a segment, which is the last couple of examples that we've done there. Okay, so those are our basic terms, and like I say, you can pick up marks just for knowing what those words apply to in relation to a circle. Okay, circumference. We've got two formulae for that, pi d or 2 pi r. Don't forget that the diameter, which goes all the way across through the centre circle, got the diameter that goes all the way across, there's a radius here and a radius here. So that just means that the diameter is 2 lots of the radius. So formula for the circumference is pi times the diameter, or it's 2 pi r, just because the diameter is the same as 2 lots of r. And don't forget your pi value, if they want you to be accurate and on a calculator paper, you'd be expected to use the value on your calculator. Otherwise they might ask you to take an approximate value of pi. They might say take a value of pi of 3 or 3.1 and then use that in your calculations. They might actually ask you to, well, leave the answer, leave the solution in terms of pi. So whatever other calculations you do in multiplications, you're going to have a pi in the answer. Okay? You don't actually have to apply a value to pi. Okay, so you need to know those formulae. They will not be given to you in an exam. The circumference is pi d or the circumference is 2 pi r. They both mean the same thing. Area of the circle, pi r squared. Again, you could have it in the exam. They'll ask you to take a value of pi of 3 or 3.1, an approximate value. They may say leave the value in terms of pi. It depends on the type of paper, and it depends how accurate they want you to be. R squared, R is the radius, so it is the value of pi multiplied by R, gives you the area of a circle. You need to know that formula. It will not be given to you in an exam. Okay, and moving on. What have we got here? We've got a semicircle, a half circle. So, let's just think about this. If we were dealing with a half circle, could we actually find out the area of that? Yeah, we could. Because the area of the whole circle would be pi r squared. Because it's a semicircle, a half circle, we just divide that by 2. And that would give me the area of my semicircle. They've given us some dimensions that we can work with. Could we work out the area? Yeah, we could. A little trick, it's not really a trick, it's to make sure that you understand what you're doing. They might give you the value of the diameter, and you being the top students that you are, you'd realise, okay, they've given me the diameter. To use this formula, I need to find the value of r, which is actually half the value of the diameter. Okay, so don't be caught out by that. What about, they gave you quarter circle. Okay, might be that they give you the quarter circle, so they've given you the value of r. They might have given you these values. Yeah, r's going to be the same each time. It's a quarter circle, probably denoted by the fact that they've got a right angle in there for you. So the area is going to be pi r squared divided by 4. Okay? Because it's a quarter of a circle. It's a fourth of the area of the whole circle. So work out the area of the whole circle, divide it by 4, that will give you the area of that quadrant, that quarter circle quadrant. Okay, now there's more advanced questions, the more difficult questions might be looking at that idea of a sector. Okay? Now, what are we going to do about that? If they asked us to find the area of a sector, generally what they'll do is they'll give you a size of an angle. So they might tell you that that angle there is x degrees. So how many degrees you've got in a circle all the way around? You've got 360 degrees. So what fraction of that circle is that area going to be? So the area of that sector is going to be x divided by 360, and that will give us the fraction of that whole circle that applies to that sector, okay? And then we just multiply it by pi r squared, okay? So if we actually did an example of that, so let's think of an example that we could have there. So 60 degrees, the value of the angle in the sector was 60 degrees. What does that actually mean? That actually means sixty, 60, 60, 60, 60. That sector would actually be 60 degrees by 360 degrees times pi r squared. Which I think you can see from the diagram. We've divided that into equal slices. Each of them is going to be 60. 60 is a sixth of that whole circle. But in general, if we take the size of the angle, divide it by 360 degrees, multiply it by the area of the whole circle, that will give us our result. So that's for area. But they might actually want us to look at arc length. So we just go through the same process. Give ourselves some space there. They might want us to find out what's the length of that curve there. Similar type of process. The whole way around the circumference is 2 pi r. The whole way round. But what have we got this time? We've got a fraction of that. And the example we've got is we're just finding an arc length there. So let's just call that arc 60 divided by 360 multiplied by what the distance around the whole circle would be. Okay? So it's just what proportion of that whole circumference does that arc length apply to? 60 divided by 360 will give us the proportion, the fraction of the whole circumference. The whole circumference is given by 2 pi r. Now, a common question you might get is something like this. And I give you a sector like that and say, right, okay, what's the perimeter of that shape? What's the perimeter of that shape? Now, some students would work out the length of that arc and think, great, done it, cracked it, sorted it out, know how to do that. That's the proportion of 2 pi r, and the proportion of the whole circumference. But if the question asks you for the perimeter of that shape, what else have you got to do? You've got to find that arc length. Okay? But then you've got to add it to those two straight sides, which are the size of the radius. Okay? So if they're asking you for the perimeter of the shape, don't forget, find your arc length, great bit of work. But to get the perimeter of the whole shape, all the way around the shape, you've got to add these two values of r into it as well. Okay? That's been a quick bit of revision going through circles. Hopefully that's been of help to you, hopefully that's of use to you. Just quickly, we'll skip through it all just to make sure that we're 100%. So, 6 different terms, 7 different terms that we've talked about there. The idea of radius, diameter, circumference, the sectors and arcs, chords and the segments. Hopefully you've got an understanding of those terms. You need to know those formulas. The formula for the circumference, pi d or 2 pi r, you must have those in your head. Formula for the area, pi r squared. That leads you on into, yeah, can we deal with a semicircle, half a circle? Can we deal with the area? Yes, we can. It's pi r squared, the area of the whole circle divided by 2. A quadrant, a quarter circle, pi r squared divided by 4. And then if we start looking at sectors, can we find the area? Yeah, we've just got to remember that idea of 60 divided by 360. And then pi r squared to give us the area of the sector, and then 2 pi r to give us the actual arc length. The proportion, the fraction of the circumference, the proportion, the fraction of the area of the whole. Okay? And then finally, don't forget, if you're asked to give the perimeter of that shape, which is a sector of a circle, yeah, great. The main part of the question is going to be to find out arc length and show your understanding of that, but don't forget to get your full marks for the perimeter of that shape. You need to add in the straight lengths as well. Right, hopefully that's been helpful. Thank you for your attention. Well done.